Melindy with her calf. You can just see underneath there. She is about 6 weeks old, and she's the latest calf we've had at Chester. The black rhino is critically endangered in the wild, with less than around 5,000 individuals left in the wild. And the eastern subspecies, which is what we have here, there are probably less than about 800 left in eastern Africa. Because the species is so endangered in the wild, the conservation breeding programme is really vital. And when we started using hormone analysis to understand the reproduction of the species here at Chester Zoo, we realised that there was sort of differences between individuals in how well they were breeding. And we actually expanded that question to the whole of the European population of black rhinos in European zoos to try and understand how we could improve reproductive success. We collect faecal samples from the rhinos, both here at Chester and from all the black rhinos all over Europe, and those samples are sent here to the Wildlife Endocrinology Lab at Chester Zoo. We essentially measure the hormones in those faecal samples, and that tells us when a female is likely to be receptive to the male. We can tell if a female's pregnant and when she's likely to give birth, and it just gives us a better idea of what's going on with the population. Here at Chester Zoo, we hadn't actually had a black rhino birth for 10 years before this project started. But with building in the hormone analysis as part of our sort of daily routine, it helps the team understand a bit better what's going on with their animals. Since that time, we've had 4 births, so it's made a real difference in terms of managing the group that we have here. We would hope that in a captive breeding programme such as this, where obviously there are limited individuals because it's such an endangered species, we would like, ideally, every individual to reproduce and leave offspring into the future generations. But that's not necessarily what we're seeing, and that's why this project was so important, is because we can't really afford to lose any genetics from the population. So by understanding why there are differences between individuals, we can see if there are changes that we need to make in terms of how we manage that population. And so with a better understanding of sort of what affects their reproduction, we can hopefully increase the growth of the population. The threat of poaching is ongoing, and so we really need to make sure that we have sufficient individuals and sufficient genetic diversity, that it provides a long-term sort of backup for the species. It's lovely to actually be able to see an end result to your research, and obviously when it's such an important species and such a charismatic species that we love to have at the zoo, it's amazing to be able to come down here and see a baby rhino running around because of the work that we've done in the lab and worked with the team, and it's actually, you can see the real results of the project. It's brilliant.